So hello guys, my name is Josh and today I'm going to be doing my math assignment on critical paths. So essentially what a critical path is a critical path is used for basically organization of a project. It is a path through the network along activities that cannot be delayed without delaying the entire project. So this is mainly used by people that are under time heavy sort of circumstances where they need to have the most efficient timing to get their project complete. So the first step you're going to want to do when doing one of these is organizing a table that looks similar to something like this. So you're going to be a person that's organizing a event for school or whatever. So for this, we're going to have about 1, 2, 3, 4, 5, 6, 7, 8, 9, 9 activities, and this includes arriving at the event site, allocating jobs to your workers, etc., etc. So you want to letter these in alphabetical order. And then next you want your activity, so arrive at the event site. And this obviously has no predecessor, so nothing needs to be completed before you can arrive at the event site. So nothing here, and also this will take 10 minutes. Once you arrive, you will allocate jobs to your workers, and the only thing that needs to occur for this to happen is A, which is arrive at the event site itself, and this will take 5 minutes. So then from C, you organize a stage, and you need to have allocated jobs to workers for this to occur. So the only predecessor for this is B, and etc. So this goes on. Preparing sound, you need to have had organized stage, organized lights, and organized performance and costumes for this to occur. So once you have organized your table, you want to have a network that looks something like this. So this is a very basic one for this table right here. So you have A, which is arrive at the job site. Nothing needs to have occurred before it. And so it's just one line, which leads to B, which is allocating jobs, F and H, and they were download the music track and organize performance and costumes, and this can be happening at the same time while this is occurring. And then so 3 minutes, 13 minutes, and etc. So it goes on C, D, G, I, E, and it just continues along. So once you have completed this, you have your time and your letters for all the events that will be occurring. You want to get rectangles with triangles in them, and this is going to represent your forward scanning. So once you have organized and placed rectangles and triangles into your network, you want to begin your forward scanning. So for this to be completed, you start it with the triangle on top, which is 0. You then, so plus 10 minutes, you go across, so that's 10, and then 10 plus 5, 15, 15 plus 6, 24. I know that's not 24, I'll get to that in a sec. So 15 plus 6 would be 21, but in order for this network to work, we have to use the highest possible number, and this would be along this line here. So 10 plus 3 is 13, 13 plus 11 is 24. So we need that number to be 24 because it's the highest possible number there, so we can have our total amount of time it will take to complete this network. 24 plus 10 would be 34, but we have a 15 here, so we have to add the 15, which is 39, then 54. Then we're going to want to do this backwards in the rectangle, so 54 minus 15, 39. 39 minus 15 again, highest number, 24. 24 minus 6, 18. 24 minus 11, 13. So we just have a little error here, so I'll just quickly fix that up. It's going to be a bit dodgy, but 18 minus 5 is actually 13. And then that would be a 3. 13 minus 10, 3. So there we go. And now, while we're just on the topic, I'm just going to want to discuss float time. So float time is the difference between those paths that cannot be delayed and those that can. Float time indicates which the activities can be delayed without delaying the completion of the whole test. So an example of float time on this particular network would be here. So obviously the fastest path here is 14, whereas this one's 13. So if we were to complete H, we'd have 1 minute of extra float time, or not so much wasted time, but it's time that could be used elsewhere. So that's 1 minute of float time here. And that essentially wraps up everything that needs to be discussed for the critical path. So thank you for listening. This is Josh, and yeah. Oh yeah, and in order for this path to be considered, so the answer for this would be this path here, as it is the fastest possible completion rate.